Okay, so on this question, it says students in a stats class took their second test. Following our scores they earned, create a frequency histogram, da 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 da. Ignore this part. Class width is 10. Okay, so basically here's some scores from some students in a stats class, their second test. These don't look so good. Maybe this is just like a quiz or something. 67, 55, 58, 46, 26, etc., etc. Since the data were collected um, for one quantitative variable. Now, why do we say that? Well, they're not collecting two things, meaning they're just collecting score. They could have collected score and gender. Like, did the boys do better or the girls do better, right? So for every student, they could record their score and their gender, or their score and how many hours they studied, or their score and their age, or we could have recorded other variables other than just their score, but we only recorded one variable, their score. And it's a quantitative error, meaning it's a number. It's not we could have recorded their eye color or their hair color or their gender or their race or something like that, right? That would have not been a quantitative variable, but we just recorded their score, which is a number. It's a quantity. It's a quantitative variable. So the correct graph to make then is a histogram. A histogram is the same basically as a bar chart where the bars touch. And so when you have numbers, you want the bars to touch. Why? Well, if you had favorite color, went around the room and asked everybody their favorite color, blue, red, orange, you wouldn't want those bars to touch because a blue bar touching an orange bar, that wouldn't make any sense. What if you chose blue? That means your favorite color was almost orange. And I know, no. But with numbers, you want them to touch because if you got in the 50s, that means you're right next to the 60s, right above the 40s, etc. Numbers you want to touch. When the bars touch, we call that a histogram. All right, so for this one, the class width is given to be the following 10. They told us that up in the words. Class width is 10. Okay, and now complete the table. So it starts us at 20. And so if you're going to go up by 10, if you're going to add 10, you're going to be at 30. And then this one will be 30, add 10, 40, 40 to 50, 50 to 60, 60 to 70. Now, how do we get the frequencies? Well, basically, frequency means how many. How many got between 20 and 30? I don't know. Let's go up and see. That person, and that's it. One person. How many got between 30 and 40? I'm seeing this one, and this one, and this one. Three. Great. Good. How many got between 40 and 50, like in the 40s, basically? One, two, three, four, five, six, seven, eight in the 40s. Yeah, eight. That's right. Okay, keep going. How many got between 50 and 60, like in the 50s? One, two, three, four. Sure enough, four. And finally, how many up between 60 and 70? That one right there, one, one. So there's the frequencies. How do you figure out the relative frequency? That always means the part over the total. So this is one. Now, what's the total? If you add these up, this is what, 5, 13, 17 total. 17 total students. Maybe it said it somewhere too. Yes, it didn't. 17 total students. So 1 out of 17. If you divide that in your calculator now for the calculator, oh, that's not the calculator. Go to the calculator. Hello, trouble. There we go. Yeah, so you could use your handheld calculator, or you could click on the calculator on the home page of the Canvas course. It'll show this. I'm going to go to number 2. You can go to any of them, but don't go to number 1. So I'm going to go to number 2. Roll down to the bottom. There's a scientific calculator there, or you could use the one that you have on your own. So 1 divided by 17, is that what it was? 0.05882, 0.05882. So 0.05882. And it said round to 3 places. So you good with rounding? So 3 place right there. That tells me to round that up 0.059 because the part after the line's an 8. There it is, 0.0. Whoops, I kind of scribbled that. 0.059. Good. The next one is going to be what? 3 out of 17. Go to your calculator. going to be 3 out of 17. I'm getting 0.17647. 17647. And then round to, what's it, 3 places. So 0.176. Here it is. Next one is 8 and 17. Calculator, 8 out of 17. 0.4705. 0.4705. Round to 3 places. 3. Now that 5 means round that up, huh? 0.471. That's what they got. Next one is 4 out of 17. There we go. Okay, 4 out of 17. And that's 0.2352. 0.2352. 2. We're supposed to round that to 3 places. That says leave it. 0.235. That's what we got. Last one is 1 out of 17. Actually, we did that one up here. That's 0.059. We got it. We're done. Now, having done that, now they want us to say, okay, which one of these is the right bar graph or histogram where the bars touch? Well, we can see if we were to make a little bar chart real quick. I'll do it maybe right here. And I was to say, okay, I'm going to go 20. Oops, it's kind of scribbly, huh? I'm going to go from make this mark the 20s and make that the 30s, go a couple over, 40s, 50s, how far supposed to go? Okay. 60s, there we go, good enough. 70s, okay. So the bar between the 20s and 30s is supposed to come up to 1. So I'll just go up like 1 line. Boom. And the bar between the 30s and 40s is supposed to come up to 3. So this would be 1, 2, 3, 4, 5, 6, 7, 8. So the 30s to 40s is supposed to be 3. 3. 40s to 50s is supposed to come up to 8, all the way up here. And next one, 50s to 60s, 4. So where's that? 1, 2, 3. There's my 4. It's kind of scribbly. Sorry, 1, 2, 3, 4, right about there. Like that. And 60s to 70s, only 1. Like that. That's what it should look like. Which one of those looks like that? Um, I think it's this one. These look close. See how this one here is at 3, and this is supposed to be 3, and this one's at 4. Otherwise, they're really close. It's this one. See, and this is 1, 3. This is 1, 1 there, 3, 8, 4, 1. So 1, 3, 8, 4, 1. That's the correct one. The other one's close. 1, 4, 8, 3, 1. It's off a little bit. Yeah, so anyway, it's this one. Okay, there's the right histogram. Now, what shape is that? Well, that's a bell curve. Bell, meaning like, it looks like a bell. It looks symmetric, doesn't it? See how it looks like a bell, sort of? We call that a bell curve, a normal curve. It's symmetric. We'll talk more about that in days to come. So there we go.